So my name is Yelyzaveta Baran. I am ophthalmologist from Chernihiv City, Ukraine. I have no financial interest related to this presentation. So routinely, all cases of cataract surgery finished by implantation of intraocular lenses. And now we have two opportunities: hydrophilic or hydrophobic intraocular lenses. And as surgeon, as patient want that this lens can serve for whole patient's life. But reality is not so kind to us, and hydrophobic lenses can accumulate water in its material that is called glycerin, and hydrophilic lenses can just lose their transparency, which is called opacification. So the main goal of this presentation is to describe different patterns of IOL opacification and to describe underlying causes and implications for patients. And our study involves 16 patients that have varying degrees of vision loss, and they required IOL explantation. So after explantation, all IOLs were examined by light microscopy, scanning electron microscopy, energy dispersive X-ray spectroscopy, and alizarin red staining. And during investigation, we found at least 5 different patterns of IOL opacification. And the first one is a tree-growth ring pattern. It's characterized by concentric rings, which presented as medium to large size round lesions that expand from periphery to the center of IOL. And what is interesting that this type of opacification occurs in areas that are not covered by capsule. Second one is mosaic pattern. It's characterized by small-sized square lesions, and they aggregate into a larger zone of opacification, and it also occurs in the center of IOL. Third one is night starry sky. Separate dispersed small-sized round lesions that aggregate to form a larger form of opacification. 4 is frozen lava pattern. This is a single large zone of opacification consisting of densely packed cell-like structures, and under high magnification you can see demarcation lines between these cells which resemble the texture of frozen lava. 5 fish caviar pattern. It's one large zone of opacification covering the IOL surface, and most cells within this pattern have a bright white center. So in all 5 patterns, elemental analysis through EDX resembling a consistent composition of calcium and phosphorus deposits with the calcium to phosphorus ratio approximately of 3:1. And the deposition of calcium and phosphorus can be a multifactorial process, and potential risks are metabolic disorders or previous surgeries or prolonged exposure to inflammatory cytokines. And while not all patients with hydrophilic IOL can experience IOL opacification, but those who do are at significant risk of IOL explantation. So, in conclusion, our study demonstrates that these opacifications of hydrophilic lenses primarily driven by calcium and phosphorus deposits, and the implication of these findings are significant for both patient's care, future lens design, and future managing of complications. Thank you very much.